Today we're going to look at similar triangles, and we're going to experiment with them using GeoGebra. So the way that this works, you can see the links on the site. What we're going to do is we're going to take two triangles, and we're going to see that these two are in fact congruent. I'm going to set them right on top of each other here. So these are two congruent triangles. And what we're going to do is scale one of them so that it grows relative to the first. So the scale, now if we go less than 1, it will shrink, but if we go greater than 1, it will grow. So let's go ahead and get it up to a scale of 2. So what we're looking at right now is that this larger triangle, every side length is twice as long as the original triangle. And if you look at it visually, that seems to make a bit of sense. C looks like it's the midpoint of D or A, depending on which triangle you're looking at, all the way up to F over here. And B looks like it's at the midpoint of D to E. And so this line segment right here from E to F corresponds to B to C, and that one also looks to be about twice as long. So what we did here is we formed a common ratio. Every time we have a corresponding side on one triangle to the next triangle, we have a ratio of the scale factor, 2 to 1. If we grow our scale factor all the way up to 3, you'll have the same thing. Each one of these corresponding sides, this side to the smaller one here, the smaller side to the larger one here, it's all going to be a 3 to 1 ratio that we're looking at. The one thing that you may have noticed is that even though the side lengths are changing throughout all of this, the angles do not. So this angle here for the smaller triangle, angle A, or the larger triangle, angle D, is the exact same no matter what scale we use. Same thing with this second angle here, angle B or angle E, which correspond to each other. They're always the exact same angle no matter how big the other triangle is. And even though it's not marked, angles C and F also, given that the three angles add up to 180, must be the same. So let's move over to another GeoGebra worksheet, looking at specifically proportions. And I also have this link below. If we go ahead and change one of these triangles, the other triangle is going to change so that it is, in fact, similar. The way that it does this is all the angles are maintained to be the same. So angle C corresponds to angle F, and those two will always have the same angle. B to angle E, and A to angle D. But we can scale the triangle on the right by grabbing a hold of point F and shrinking it down. So if we shrink it down to about here, try to get that exactly right. But what we're going to be able to do then is get the two to be equivalent. We're going to get the two to be congruent triangles. So you can see, even though it's not perfectly exact, it's very close right now. And what we can do, we can go ahead and drag this one out and scale it. And let's get this one here to some integer lengths so that it's easy to make some comparisons. So we have 3 on one side. We're going to go for about 4. Again, because of the decimals here, it's a little bit hard to get exactly what you want. But we have a 3 side, a 4 side, and this side we're going to, we can get that one to about 5. If you remember 3, 4, 5, you're going to be looking at a right triangle. You move this down here, and if we can get this hypotenuse, this longest side here, to be about 10, you'll notice that each of the other ratios are exactly the same. This 10 to 5 corresponds to 6 to 3, which, you know, 6 divided by 3 is also 2. And 8.08 to 4.04, you're looking at, again, a ratio of 2 to 1. What if we grow this a little bit? If we can grow this side to 15, side EF. It's a little touchy again, but let's get it pretty close. So roughly 15 to 5, 15 divided by 5 is 3, so this side is 3 times longer than its corresponding side here. Here you're going to have roughly 9 divided by 3, again 3 to 1, and roughly 12 divided by 4, again 3 to 1. So whenever you're dealing with similar triangles, the proportions of corresponding sides will always be the same. And it says that down here. AB divided by DE, now these are both referring to lengths of the sides of the triangle, is going to be equal to AC over DF. Because angle A and angle D are corresponding angles. B and E are corresponding angles, and C and F. So what I want you to do is go ahead and try both of these GeoGebra worksheets by moving around the triangles, resizing them, seeing what happens if you rotate them. So on this one you can actually rotate them and see how that affects things as you grow things. The proportions may appear to be off, but you have to remember what sides actually do in fact correspond. And see what you come up with. We'll discuss this again later. That's it.